Beneath the southern Indian Ocean, closer to Antarctica, lies something that shouldn't exist, a hidden continent almost no one talks about. Known as the Kerguelen Plateau, this continent-scale volcanic giant is one of the largest geological structures on Earth, yet it remains almost entirely drowned beneath the sea. It was born during a violent moment in Earth's history, when the supercontinent Gondwana tore itself apart and unimaginable volumes of magma flooded the ocean floor. For decades, scientists believed this vast system was long dead, but new signs of activity are forcing a disturbing question. Can a volcanic structure the size of a continent ever truly go silent? Before we continue, a quick word about today's sponsor. If you work with PDFs often, UPDF 2.0 is worth checking out. It's a PDF tool we've been testing recently, and it comes with some useful features that make everyday work much easier. Inside UPDF, we can edit text directly, which is usually tricky in PDFs, and even change fonts while editing, which is genuinely useful. What stands out most is UPDF's inbuilt AI assistant. Powered by GPT-5 and DeepSeek, it lets us chat directly with a PDF to summarize or improve sections, like refining this CV. And for longer documents, it helps us quickly understand the content without having to go through every page. For sensitive files, UPDF also lets us protect PDFs with passwords and share documents securely. Beyond these, it includes a wide range of other practical features. UPDF works across Mac, Windows, iOS, and Android, supports one account on 4 devices, comes with lifetime free upgrades, and offers responsive customer support. There's a limited time offer available. Click the link in the description to check it out. The Kerguelen Plateau occupies a vast region of the southern Indian Ocean, stretching over nearly 2 million square kilometers. Most of it lies between 1,000 and 3,000 meters below sea level, with only a small portion breaking the surface at the remote Kerguelen Islands, often described as some of the most isolated landmasses on Earth. Beneath the waves, however, the plateau is anything but modest. Its crust is extraordinarily thick, in places exceeding 20 kilometers, far greater than normal oceanic crust and rivaling continental dimensions. Geologically, the plateau belongs to a rare and powerful class of features known as large igneous provinces. These form when enormous volumes of magma are released over relatively short geological timescales, flooding the surface with basalt and permanently reshaping the planet. The Kerguelen Plateau began forming roughly 120 million years ago, during the breakup of the ancient supercontinent Gondwana. As India, Antarctica, and Australia began to drift apart, a deep mantle plume, now referred to as the Kerguelen hotspot, rose toward the surface. Instead of producing a single volcano or island chain, this plume generated sustained, massive outpourings of magma that built the plateau layer by layer. What makes the Kerguelen Plateau especially unusual is its hybrid nature. Drilling and geochemical studies have revealed fragments of continental crust embedded within the volcanic basalt. These rocks do not belong in the middle of an ocean basin. Their presence suggests that parts of Gondwana were stretched, thinned, and partially incorporated into the growing plateau. In effect, the Kerguelen Plateau was not purely oceanic, nor fully continental. It was something in between, a geological experiment that nearly became a new landmass. Yet gravity and time had the final say. As volcanic activity waned and the crust cooled, the plateau began to subside. The immense weight of the basalt, combined with tectonic stretching and thermal contraction, caused it to sink. Sea levels rose, and the plateau drowned, leaving only its highest peaks exposed. What remains today is a failed continent. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Although hidden beneath the ocean, the Kerguelen Plateau plays an outsized role in shaping how the planet's oceans behave. Its submerged topography acts as a massive obstacle to deep and intermediate ocean currents circulating through the Southern Ocean. water masses flowing between the Indian, Pacific, and Atlantic Oceans are forced to bend, slow, or redirect around the plateau's edges, altering patterns of heat and nutrient transport. This region is especially important for the formation of deep ocean waters that help drive global circulation. Cold, dense waters formed near Antarctica sink and spread northward, influencing climate systems far beyond the southern hemisphere. By shaping the pathways of these currents, the Kerguelen Plateau indirectly affects how heat is redistributed across the planet. Even subtle changes in this system can have long-term climatic consequences, influencing temperature patterns, carbon storage in the deep ocean, and the stability of polar ice. In this sense, the plateau functions like a submerged piece of planetary infrastructure. It does not generate weather events or disasters directly, but it helps regulate the background conditions upon which Earth's climate operates. Understanding its structure is therefore not just a geological exercise, but a necessary step in understanding the ocean climate system as a whole. The Kerguelen Plateau formed during one of the most turbulent periods in Earth's environmental history. Large igneous provinces are closely associated with global stress events, driven by massive volcanic gas emissions that disrupted atmospheric chemistry and ocean conditions. The rapid release of carbon dioxide, sulfur dioxide, and other gases during their formation often exceeded Earth's natural buffering capacity, triggering widespread environmental instability. In the case of the Kerguelen Plateau, volcanism unfolded during the Cretaceous period, a time marked by warm global temperatures, high sea levels, and episodes of oceanic anoxia, intervals when deep ocean waters became depleted of oxygen. While the plateau alone cannot be blamed for these changes, its formation contributed to a broader pattern of planetary instability. The sheer volume of magma involved implies sustained gas release and heat transfer into the ocean, processes known to disrupt marine ecosystems and climate equilibria. These ancient precedents matter because they demonstrate how deep ocean structures can influence the planet far beyond their location. The Kerguelen Plateau is a reminder that some of Earth's most significant climate disruptions were driven by prolonged, hidden processes rather than visible surface catastrophes. For much of the modern era, the Kerguelen Plateau was considered geologically quiet. It lacks the frequent high-magnitude earthquakes associated with subduction zones, and it does not host explosive surface volcanoes. But quiet does not mean inactive. Seismic monitoring has detected earthquakes within and around the plateau, indicating that stresses continue to accumulate and release within its thickened crust. The plateau lies near spreading centers and fracture zones in the Indian Ocean, where tectonic plates continue to diverge and adjust. These interactions create pathways for magma and heat to migrate through the lithosphere. Geochemical evidence from volcanic rocks on the Kerguelen Islands suggests that the underlying mantle plume has not vanished. It may be weaker than it once was, but it still exists, slowly supplying heat from deep within the Earth. This lingering activity places the plateau in a gray zone between extinct and active. It is not erupting, but it is not entirely dormant either. In geological terms, it is a system with memory, capable of responding to changes in mantle dynamics, plate motion, or stress conditions over long timescales. The most credible risk associated with the Kerguelen Plateau is not a sudden, explosive catastrophe, but a large-scale submarine volcanic or tectonic episode unfolding, largely unseen. If hotspot activity were to intensify, even modestly, it could trigger widespread magma intrusion beneath parts of the plateau. Such activity could produce extensive submarine eruptions, releasing heat and chemically reactive fluids directly into the deep ocean. The immediate effects would be largely invisible at the surface, but severe below. Volcanic gases, acidic fluids, and metal-rich emissions could disrupt ocean chemistry, stressing deep-sea ecosystems already adapted to narrow environmental limits. Such changes could lead to the collapse of deep-sea organisms, reduced oxygen levels, rising acidity, and the accumulation of toxic elements. Heating of surrounding waters could destabilize methane hydrates and weaken sediment layers, increasing the risk of large underwater landslides and additional greenhouse gas release. At a broader scale, deformation of the plateau could disrupt southern ocean circulation. Changes in seafloor topography or heat flux could alter deep water formation, weakening a key component of global heat and carbon regulation. These would not be rapid disasters, but slow-moving disruptions unfolding over decades, quietly reshaping planetary systems before their consequences become fully apparent. What makes this threat particularly concerning is its invisibility. The plateau's remoteness and depth mean significant changes could progress undetected, with consequences emerging only after they are already underway. The Kerguelen Plateau matters not just as a scientific curiosity, but as a reminder of how deeply connected Earth's hidden systems are to life at the surface. For scientists, it sits at the crossroads of geology, oceanography, and climate science, offering rare insight into how continents break apart, how mantle plumes behave, and how massive volcanic systems interact with the oceans over millions of years. Understanding structures like this helps refine models of Earth's internal heat flow and the stability of the ocean currents that regulate global climate. But the stakes go far beyond theory. Because the plateau lies far from land and far below the surface, it represents a class of risk that is poorly monitored and poorly understood. Subtle changes here could alter ocean chemistry, disrupt marine ecosystems, and weaken the food chains that support global fisheries, quietly threatening food security long before the cause is recognized. The Kerguelen Plateau does not loom over cities or announce itself with catastrophic earthquakes or tsunamis. Its danger lies in its scale, its invisibility, and its link to forces that reshape the planet slowly, methodically, and without warning. Earth has rewritten itself before through structures like this. The machinery that built the plateau has not disappeared. It has merely fallen silent beneath the waves, waiting.